Hello, Introduction to Philosophy students. Welcome back to our lecture. This week we will be talking about Chapter 2 of our class textbook, Ultimate Questions. The title of that chapter is Philosophical Tools. So first, I will introduce some preliminary concepts, and then I will talk about what arguments are, how they're structured. Then we'll talk about two specific kinds of arguments, deductive arguments and inductive arguments. And I just wanted to recommend that you break up this lecture into smaller parts because there's a lot in each part. So a good way to break up the lecture is by these headings that I've introduced here, and to take some time to do deductive and inductive arguments separately so you're not trying to get all that information into your head at one go. So some preliminary concepts. So there are three concepts that the author introduces at the beginning of this chapter that it's important to understand, and that you can kind of think of adding these concepts into your little toolkit, and they will become relevant as the semester goes on, and you will need to understand these concepts for the work that we're going to do within this textbook as the semester progresses. So it's important to make sure you have a good grasp of all of these three concepts. So the first one is logical consistency. What is logical consistency? Well, they say two claims are logically consistent if it's logically possible for them to both be true at the same time. Okay, so if you have two claims, if they can both be true together, then they're consistent. If it's not logically possible for them to both be true at the same time, then they are not consistent. They're inconsistent, logically inconsistent. So what is an example? Well, here's an example from one of the exercises on page 17. I am the same person I was when I was 5, and everything changes. So the question is, are these two sentences logically consistent or not? That's a question for you to answer. And you can look on page 17 at the remaining examples and try to determine whether they're logically consistent or inconsistent. Sometimes it's not always clear whether two statements are logically consistent or not. The next concept is logical possibility. So for something to be logically possible, and again, possibility was part of the definition of logical consistency. For something to be logically possible means it doesn't entail a contradiction. And a contradiction is when you both assert and deny that something is the case. Okay, that would be contradictory. The author distinguishes logical possibility from another kind of possibility, causal possibility. So with causal possibility, we're talking about whether something is possible given the laws of nature. Something is within the realm of the laws of nature. Here's an example of these two kinds of possibility. So in the first sentence, we have, it is not possible for LeBron James to throw a basketball more than a mile. And in the second sentence, it is not possible that LeBron James is both taller and shorter than Kobe Bryant. Let me change that. It is not possible that LeBron James is both taller and shorter than Kobe Bryant. Okay, so which kind of possibility do you think is at work in these two sentences? Well, the first one, it is not possible for LeBron James to throw a basketball more than a mile, just means it's not within the laws of nature. It's not within the laws of physics for LeBron James to throw a basketball more than a mile. At least on Earth, it just doesn't work that way, given the physical laws. But it wouldn't be contradictory for LeBron James to throw a basketball more than a mile. We can imagine another planet where the laws work differently, or there's less gravity, or something like that, where LeBron James can throw a basketball more than a mile. So there's nothing contradictory in that statement. It's just not possible given the laws of nature that we have at play here on Earth. The second kind of possibility here, it's not possible that LeBron James is both taller and shorter than Kobe Bryant. is logical possibility. So for LeBron James to be taller and shorter than Kobe Bryant means it just doesn't make any sense. How could LeBron James be taller than someone if he's also shorter than that same someone? Because when you're shorter than someone, you're not taller than they are. And when you're taller than them, you are taller than they are. So this second sentence is contradictory because it's both asserting something to be the case and denying that it's the case. So think about our first concepts now, logical consistency. Now, is it logically consistent that LeBron James is taller than Kobe Bryant and that LeBron James is shorter than Kobe Bryant? No, that is not logically consistent. It's not possible for both of those sentences to be true at the same time. It's impossible. It's logically contradictory. You can't even imagine what it would be like. One way the author helps us understand the difference between logical possibility and causal possibility is to ask if we could put this thing in a movie. Because if you can put it in a movie, then even though it may not be causally possible, that means it may not be possible given the laws of physics, laws of nature, if you can put it in a movie, it has to be logically possible, because logically impossible things are just, we can't even make sense of them. They just don't make any sense. Like thinking that LeBron James is taller and shorter than Kobe Bryant. That just doesn't make any sense. Okay, the final preliminary concept that we get from this chapter is a distinction between real and lexical definitions. What does that mean? Well, when you look up a word in the dictionary, the definition you get is the lexical definition. And the lexical definition is just an attempt to say what people are doing when they use the term, people within a certain language. What are they doing when they use that word? What do they mean by that word? That's what dictionaries are trying to tell us. Dictionaries are written by people, and when they write the definition of a word, what they're trying to get at is how the native speakers of a language use that term. A real definition is something different from just trying to capture how people use the term. When we look for the real definition of something, we're trying to understand the nature of that thing, like what that thing actually is. So, for example, we might wonder what it is to be free, what it is for humans to be free, to make their own choices. And looking up the answer in a dictionary is not going to really help us answer that question. It's not going to help philosophers answer that question because they're not concerned with how people generally use the word free. They're interested in something else, in the nature of freedom, in what it is to be free. And one of the ways that they approach questions of real definitions is by trying to give necessary and sufficient conditions. So in the book, they give the example of a person. So what is the nature of a person? You can look it up in the dictionary, and they'll tell you how people in English-speaking communities use the word person, but we're not interested in that when we ask in philosophy, what is a person? Instead, we're interested in understanding what is the nature of personhood. And there will be different definitions offered in the form of necessary and sufficient conditions to say, no, this is what it takes to be a person. And people will disagree and say, no, this is what it takes to be a person. And then they can try to give arguments, we'll get to that, for why they believe the views that they do. So when you give necessary and sufficient conditions, you're giving, if you give a necessary condition, you're saying something that has to hold true in order to count as the thing that you're giving the necessary condition for. So, for example, in order to be a dog, it's necessary that you are an animal, right? If you can't be a dog if you aren't also an animal. So being an animal is necessary for being a dog. We're saying, what does a thing A have to have in order to count as a thing B, a kind of thing B? Okay, so a necessary condition is something A has to have in order to count as a B. Okay, and when you're just using A and B as any generic predicate. A sufficient condition means that as long as you have that, it's enough to count as a B, right? It's enough for A. If A has a sufficient condition to count as a B, that means A will count as a B. Okay, so being a dog is not a sufficient condition, being an animal is not a sufficient condition for being a dog, because there are lots of things that are animals, like myself included, that are not dogs. Okay, so it doesn't have a thing that's an animal, a thing A being an animal is not sufficient to classify that thing as a dog. It takes more than that. Even though it's necessary. Being an animal is necessary for being a dog. It's not sufficient for being a dog. Now, is being a dog sufficient for being an animal? Yes, because once you're a dog, you've made it. You count as an animal. You get to count as an animal. Okay, so those are necessary and sufficient conditions. And in this chapter, there are exercises that help you to try to identify necessary and sufficient conditions. And those will be good exercises to do to make sure you understand these concepts. And in general, in this chapter, the food for thought exercises will be really helpful to practice for doing well on the quiz on this chapter. When we provide necessary and sufficient conditions, we're trying to capture the definition of the term with those necessary and sufficient conditions. And what a definition is trying to do is it's trying to give us a way to understand a term that's going to classify everything that falls under that term as falling under that term. And everything we want to not count under that term should be ruled out by our definition. So if we are giving a definition of person, for example, then we want it to count all the obvious instances of people as a person. And we want it to rule out things that we don't think are people, like perhaps aliens or non-humans. Okay, so we want the definition to sort of draw the line between, in this case, what counts as a person and what counts as not a person. We want it to draw that line in the right place. And a way to object to a given definition is by offering a counterexample. So a counterexample is going to say, well, here's an example of something that doesn't count as an X, but under your definition of X, it ought to count as an X, but we know that it's not an X. Okay, so it's a counterexample to your definition, because what it shows is that your definition has drawn that line in the wrong place. Okay, so if I say, let's stick with our being a person example. So if I say that being a person means you are rational and self-aware, and that's what I've proposed as the necessary and sufficient conditions, and you say, well, no, my grandmother was in this terrible accident and she is still a person, but she's no longer rational or self-aware, then you have potentially produced a counterexample to show me that my definition of person needs to be revised. Or with that definition, rational and self-aware, you could even say, how about my friend who's asleep next to me? She's not rational or self-aware, but she clearly counts as a person. So we need to change the definition to accommodate this obvious case of a person. Okay, that's how a counterexample can provide an objection to a proposed definition. The reason it's important to understand all this stuff is because we're going to do a lot of philosophy that involves analyzing definitions, analyzing concepts, and understanding the necessary and sufficient conditions that have been offered as capturing the definition of those concepts. And then we're going to read arguments that there are counterexamples to those definitions that suggest that maybe the definition has not gotten it right yet. Maybe the proposed definition has not drawn that line between what counts as falling under the concept and what does not count as falling under the concept in the wrong place. That's how counterexamples serve as objections to definitions. And there's a lot of good practice on these issues on pages 23 and 24 of this chapter. Okay, moving on to arguments, now that we have some preliminary concepts. So an argument is a set of premises put forth in defense of some conclusion. That is, whenever you're trying to convince somebody that some claim is true and you offer reasons in support of that claim, you're providing an argument for that claim, which is the conclusion. The conclusion is the thing you are trying to defend or support through your reasons, which are the premises. And arguments are ubiquitous. They are everywhere. You can find them all over social media. If you participate in social media, you can find them in television commercials, billboard ads, newspaper articles, conversations, even sometimes art presents an argument. So one fun thing I like to do with my students is have them go out into the hallways in a classroom and find an argument on the walls somewhere. And they always succeed just by walking a few feet. So you're never far away from an argument. In this class, we will often write arguments in standard form, which means we'll try to separate out each of the reasons that we're giving in defense of our conclusion, and then we'll draw a line underneath those reasons, like I've done here, and state the conclusion below the line. Okay, so this is an example of an argument written in standard form. The argument here is premise 1, blueberries are amazingly delicious. Premise 2, blueberries are incredibly nutritious. Premise 3, everyone loves blueberries. Therefore, the conclusion, blueberries are the best food on the planet. Now, notice I didn't say in order for something to count as an argument, it has to be a good argument, because this is a very bad argument, but it's still an argument because I'm offering these premises, these reasons in support of believing the conclusion. So premises are supposed to offer reasons for believing their conclusions, the argument's conclusion. Okay, and again, there's more help on this with this stuff on page 26 through 28, the food for thoughts that begin at the bottom of page 26 here. Okay, so look through those, and that will help you be able to write arguments in standard form. And if you do any of these exercises and you want my feedback, I'm happy to provide that if you want to email me some of your work. Or another good way to approach this stuff is to share it with your group mates, see what they think about it, and have a little study session. This will all help you do better on the quizzes. Okay, so there are two types of arguments that we're going to look at in this class: deductive arguments and inductive arguments. And here is an example of each. So an example of a deductive argument is that if my brain stops working, then I won't be able to think. When I die, my brain will stop working. Therefore, the conclusion, when I die, I won't be able to think. Okay, this is contentious, but maybe you believe that you can still think after you die. But it is a deductive argument. And what makes it deductive is that it has this special feature. And the feature is that if the premises are true, the conclusion has to be true. Arguments are supposed to take us somewhere. They're supposed to deliver us from true conclusions, true premises that we accept to begin with, that we already are on board with the stuff at the beginning. And then they're supposed to lead us to something new that's also true. That's their goal. And with a deductive argument, the relationship between the premises and the conclusion is airtight, in the sense that premises of a deductive argument guarantee their conclusions. It's logically impossible for the premises of a deductive argument to be true and the conclusion to be false. And we're going to talk a lot about that in a moment. Just so you understand the other kind of argument in a rough sketch, here's an example. An inductive argument here's an example of an inductive argument. So here the first premise is all first-year students I've met are in the first-year seminar. Conclusion, all first-year students are in the first-year seminar. So here you're drawing a conclusion based on some limited number of things that you've observed directly, the first-year students you've met, and then you're drawing a conclusion that extends beyond that to some students that you haven't yet met. And that's why the inductive argument, no matter how good an inductive argument it is going to not have that airtight connection between premises and conclusions and their conclusion that the deductive argument has. Okay, so inductive arguments are a little bit messier and looser. And even if they're very, very good arguments, they don't guarantee their conclusions in that same rock solid way that deductive arguments do. So let's look a little bit more about what each of these kinds of arguments is like. So again, we have inductive and deductive arguments, and we can evaluate those arguments in two different ways. We can look first at their structure, that is the relationship between the premises and the conclusion, and then we can also consider the content of the argument, okay, what it's actually saying in the premises and the conclusion. Okay, so let me elaborate. So when we evaluate the structure of a deductive argument, we're looking for this feature of validity. Okay, so is the argument valid? And again, validity means that if the premises are true, the conclusion has to be true. And that's that, I put has to be in italics because it's that kind of rock solid guarantee. It's airtight. It's as perfect as math. Okay, it's true by the laws of logic. It has to follow. The conclusion has to follow if those premises are true. So some examples. All students have rich parents. Premise 1. Premise 2, Peter is a student. The conclusion, Peter has rich parents. Okay, now the reason this argument is effective at showing what validity is because it's an important thing to understand about validity is that the premises don't have to be true for an argument to be valid. It just has to have this special feature that I've written here, that if the premises are true, the conclusion has to be true. Okay, so if, I should have put that in italics too, actually. Let me do that. If the premises are true, the conclusion has to be true. Oh, okay, so you can see from this argument about Peter that even if the premises aren't true, the argument may still be valid, because if I wanted to change this one. There we go. Okay. If the premises are true, the conclusion has to be true. Hopefully that's pretty straightforward. You can see by looking at this argument that if it were true that all students have rich parents, and it were true that Peter's a student, then Peter would have to have rich parents, okay? Even though the premises are not true, and Peter is probably some fictional character that the author just made up for this argument, if these premises were true, the conclusion would have to follow. The same with this argument. Okay, if Tony takes drugs, then he's an irresponsible person. 2, Tony takes drugs, therefore the conclusion, Tony is an irresponsible person. So again, these premises are not true, and they don't have to be true, and the argument is still valid. And it's valid because if the premises were true, if we just grant the premises of this argument, just say, okay, let's suppose that the premises are true, then the conclusion follows. Okay, there's no way, that is, it's logically impossible for the premises to be true and the conclusion false. And that is the feature of validity. That's what validity means. That's another way of saying that if the premises are true, the conclusion has to be true. It's guaranteed. Okay, so validity is about the structure of an argument. It does not matter what the premises actually say. We can tell whether an argument is valid just by considering how it's structured and ignoring what it actually asserts. And so the way that we're going to try to illustrate the structure of these arguments is by symbolizing them. And when we symbolize an argument, where we follow two simple rules. The two rules are, if you have the same sentence, you use the same letter, and if you have a different sentence, you use a different letter. Okay, so we use capital letters to represent sentences, and we can use any letters we want as long as we follow those two rules. So if there's the same sentence being represented, we have to use the same letter, and if it's a different sentence, we have to use a different letter. Okay, so let me, just for consistency's sake here. Okay, so here you can see that I've used the letter P to represent this sentence, Tony takes drugs. That's why in the first half of this first premise, I've written if P over here to symbolize that, because I'm using P to stand in for Tony takes drugs. I'm using Q to stand in for Tony's an irresponsible person. Okay, so here's my second premise, P, Tony takes drugs, because that's what I was using P to stand for. And my conclusion, Q, because Q, again, is standing for this sentence, Tony is an irresponsible person. Okay, so take some time to make sure you understand how I've symbolized this argument. Now, this happens to be a valid argument structure. If P, then Q, P, therefore Q. And it's so common that it has a name, and the name is modus ponens. You don't necessarily have to remember that, but you should definitely remember this argument structure and know that it's valid. What that means is that it doesn't even matter what sentences we plug in for P and Q, as long as they're statements and we follow our rules for symbolization. If you have the same sentence, use the same letter. If you have a different sentence, use different letters. As long as we follow those rules, then we're going to get a valid argument no matter what we plug in here. So I challenge you now to pause the video and think of, or write down, or both. You can't really write it down if you don't think of it, but think of and or write down an argument that's different from this one about Tony that fits into this structure using our rules for symbolization to make sure you understand how to symbolize arguments and how this symbolization stuff works. Okay, I'm going to present another argument now that follows this same structure, which means because this is a valid structure, any argument that you plug in here is also going to be valid. So you should know here that this argument is also valid. You know that because it has the same structure. So, oh, I'm sorry. Nope, I did a different structure. Okay, so any argument that meets this structure is valid. So I challenge you to write your own argument that fits into this structure, which is called modus ponens. And I guarantee that whatever you write, if you follow the rules for symbolization, your argument is also going to be valid, because validity is about the structure of the argument. It doesn't involve the argument's content, and that's why I set up that grid the way I did, and we're going to come back to that. Okay, here is an argument with a different structure. Okay, if the future is already determined, then I'm not responsible for my actions. That's premise 1. Premise 2, I am responsible for my actions. Therefore, the future is not already determined. Okay, so here I haven't done the whole symbolization for you yet, because I want you to do some thinking to try to fill in the second premise and the conclusion, which are each, I'll give you a hint. Well, I'm not going to give that hint. Never mind. So can you think of the second premise and the conclusion? How would we symbolize those over here in our symbolization? So note this one's a little trickier than it might seem at first. So the first premise, I've written if P, then Q. Okay, so here, the first premise, if the future is already determined, so I'm using P to stand for this sentence. The future is already determined. Okay, and so what am I using Q to symbolize over here? Well, Q stands for I am not responsible for my actions. Okay, so how would we symbolize the second premise, I am responsible for my actions? Well, we're denying what Q stands for. We're denying that I am not responsible for my actions. Okay, so there's a double negative there. Really, we're saying it's not the case that I am not responsible for my actions. That's what I am responsible for my actions means. So when we symbolize this, we have to capture that correctly. If you just wrote Q here as premise 2, then over here it should say I am not responsible for my actions, because that is what Q stands for. But that's not what we have written over here as premise 2. We have the negation of that, the denial of that, of Q. So to deny Q, we would write it like that, not Q. And then when we deny P, we write it like this, not P. Okay, so try to take some time here again to understand those double negatives and why we put the nots where we did. Okay, so here are 3 argument structures, and I will tell you B, which we just looked at, if P then Q, not Q, therefore not P, this one is valid. Okay, this is also a valid argument structure, which means if the premises are true, if these both come out true, then the conclusion has to follow. It's guaranteed. It's logically impossible for this stuff up here to be true in argument B here and the conclusion to be false. Okay, so I want you to decide which of these are valid or invalid. So now's another time where you should pause the video, and I'll give you a moment to do that. Then I'm going to reveal the answers. Hopefully you've paused the video now, taken the time you need to really think this through, because you cannot do philosophy passively, okay? Philosophy is an activity, which means you have to do it actively. And these are definitely going to be on the quizzes, so it's important to make sure you understand them. And the way to understand them is to try them for yourself. You have to put forth the brain power here and not just hear what I have to say about it. Okay, you have to do this actively in order to understand it. Okay, so now I'm going to reveal the answers. So if you're not ready, now's your last chance to pause, but here they come. Okay, so A and B are both valid arguments, and C and D are invalid arguments. So with C and D, the premises here do not entail their conclusions. So for both C and D, it could be that the premises are true and the conclusion is false. And remember, we're saying that's just what is ruled out by a valid argument. Okay, so let me try to convince you that A and B were valid and C and D were invalid. These arguments are the way I said. Here's how I'm going to convince you. So we're going to use P to stand for you win the lottery, and Q to stand for you played the lottery. This should hopefully make it clear. And if you ever are looking at an argument structure and you're not sure whether it's valid, one way to try to help figure it out is to plug in sentences following our rules for symbolization, that if it's the same sentence, you use the same letter, and if it's a different sentence, you use a different letter. Try to plug in some sample sentences to see if the argument is valid or invalid once you get some content. Okay, but again, because validity is about the structure of an argument, not its content, any argument that you plug in, any full sentences that you plug into a valid structure will also be valid. Okay, so let's look at these 2 sentences, you win the lottery and you played the lottery, in each of those argument structures as we plug them in. So here was C. if P then Q, Q therefore P. And I said C was invalid. Okay, so if we plug in our sentences here about the lottery into the first premise up here, then we get if P, if you win the lottery, then you played the lottery. Well, that's true. You can't win if you didn't play, right? If you won, that means that you played. 2 would be you played the lottery. Well, does it follow that you win the lottery? Unfortunately, not. A lot of people, almost every single person who plays the lottery, doesn't win the lottery. Almost. Okay? Almost every single person. Okay, so hopefully this example can help you see why C, this argument structure, if P then Q, Q therefore P, is invalid. This is actually a fallacy, and a fallacy is just a mistake that you make in reasoning. And some fallacies are so common, they're mistakes that are made so often that they have their own names. So this one is actually called affirming the consequent, and it's a fallacy, and so you should be on the lookout for arguments that might commit this fallacy, because it happens a lot. Okay, this is not valid, like I said. Okay, how about argument structure A? The first premise, if you win the lottery, then you played the lottery. Then Q. Okay, that's the first premise. 2 is you win the lottery. Therefore, Q, you played the lottery. Well, yes, that all works out. It is valid, like I said. Okay, here was argument structure D, which again I said was not valid. So hopefully this will help you see why. So 1, if P, then Q. If you win the lottery, then Q, you played the lottery. 2 says not P. So you did not win the lottery. That's what premise 2 is asserting here. Does it follow that you did not play the lottery? Well, again, unfortunately not. Does not follow that you didn't play. Again, many people play and don't win, which would make the first 2 premises true and the conclusion false. And that's just what cannot happen with a valid argument. That's why this argument is invalid. Okay, there are a couple of other common argument structures that the author introduces, and a lot of these are explained on page 34. They're laid out. Okay, so you can go back to page 34 and look at these familiar argument structures, and you should be able to look at them immediately and know that they're valid arguments. So this is another valid argument structure. Either P or Q, not Q, therefore P. Okay? Again, validity tells us that if both of these premises are true, the conclusion has to be true. Premise 1 tells us that at least one of these sentences is true, P or Q. At least one is true. Premise 2 tells us it's not Q. It's not the second one. Therefore, the first one has to be true. Okay, try to explain why this is deductive to a friend or to yourself in the mirror or to your dog or somebody, because explaining these things will also help you understand them better. Okay, this is a valid argument structure. Here's another valid argument structure. If P then Q, if Q then R, therefore, if P then R. Okay, remember the line means that we're getting to a conclusion. So if you're not convinced that this is a valid structure, try to plug in some sentences into this structure for P and Q and R, and don't forget to follow our rules for symbolization, which is if you have the same letter, the same sentence, and a different letter, a different sentence. Okay, this is also valid. Okay, there's the page where these arguments are laid out if you need a refresher. Okay, so we've so far been looking at the structure of deductive arguments and claiming that they have this feature, validity, which means if the premises are true, the conclusion has to be true, but it doesn't tell us that the premises are actually true. And that's why we have lots of bad arguments, like the one about Tony doing drugs, that are still valid. So we're using the word valid in a very specific sense in this class. We're defining it in a particular way, and it's not the way you use the word valid in everyday speech. So we have a second concept, a second feature of deductive arguments that brings back in the content of the argument. Soundness, that's the feature. So a sound argument is a deductive argument that's valid and has true premises. So you'll see those first few arguments that we looked at about Tony being irresponsible. If you do drugs, then you're irresponsible. Tony does drugs, therefore Tony's irresponsible. And if you have rich parents, if you're a student, you have rich parents. All students have rich parents. Peter's a student, Peter has rich parents. Those arguments were valid but not sound. Okay, because they were valid, but they didn't have true premises. Well, if an argument does have true premises and it's valid, then it's a sound argument. And what we're aiming for in philosophy when we offer deductive arguments is that our arguments will be sound. That is, that they will have that appropriate structure of having premises that guarantee their conclusions, and they will have the right content of being actually true, of each premise actually stating something true. So if an argument is valid and it has true premises, then the conclusion has to be true, because that's what validity tells us, is that if you start with truth in the argument, you're going to end up somewhere true. Okay, so looking back at our grid here, we're still on this deductive argument side, deductive arguments. So we're looking at deductive arguments. And we just talked a lot about validity and how that's related to the structure. And we looked at many different valid structures of arguments, as well as some structures of arguments that were invalid, not valid. And now we have this new concept about the content of the argument, which brings in whether the argument is actually stating something true. So you cannot tell anything about the content of an argument from its symbolized structure, the way we were symbolizing the arguments. All that tells you is how the argument is structured. Soundness, again, tells us about the content. It tells us that in addition to having the right structure, to having the right logical relationship between the premises and conclusion, the argument also has the right content. It also actually says something that's true and correct and that we should believe. Okay, so now we're getting somewhere, since we have a sound argument in most cases. Okay, so why are we talking this much about arguments? Well, we're going to be looking at all sorts of different topics in this class about freedom and religion and morality and a lot of really important big questions about what it means to be alive and to be human and what kind of world we live in. And understanding that we can evaluate an argument on the basis of its structure and its content separately is going to allow us to think more clearly about the arguments that we encounter and what might be wrong with them, or whether they are good arguments that we should actually accept the conclusions of. Okay, so we pull these apart so that we can enhance our clarity, enhance our understanding and our grasp of the details and the complexity of the arguments that we're going to encounter, because these are very different ways that an argument can go wrong by being structured the wrong way, not to guarantee the conclusion, even if the premises were true, on the one hand, or on the other hand, to just be saying something that's not even true, even if it were true, we'd have a good reason to accept the conclusion. Okay, so pulling apart the components of the argument in this way, the structure and the content, and looking at those things separately is going to allow us to more fully appreciate the complexity of the arguments that we're going to encounter, which are important arguments about basic things that we care a lot about. So now we're going to move on to inductive arguments, which can also be evaluated on the basis of their structure and their content separately. When an inductive argument has the right structure, we call it a strong argument. So we're appealing to the notion of strength here, inductive strength. Okay, but just like validity, don't get ahead of yourself, because a very strong argument in this sense can still be a bad argument. So that's why, again, just to flag, we're using these terms in very specialized ways within this class. Okay, so a strong inductive argument does not necessarily give us a reason to believe its conclusion, because again, we're not learning anything about the content of the argument, about whether what it says is actually true, just like with the deductive arguments. Okay, so let's learn a bit more about inductive strength. And here is a good place to stop the video and go take a walk and spend the rest of the day not thinking about philosophy, so that you can come back to inductive arguments with a fresh mind, ready to absorb more information. Okay, or maybe you want to just push on through. It's up to you, obviously. Okay, so with a strong inductive argument, if the premises are true, the conclusion is probably true. I did this late at night. If the premises are true, the conclusion is probably true. Okay? So again, like I said at the outset, when we talked about the difference between inductive and deductive arguments, inductive arguments are not as perfect as math like deductive arguments. Okay? They're messier. And we never get a logical guarantee that the conclusion follows in an inductive argument, because if we did, it would be a deductive argument. Instead, inductive arguments deal with probabilities. And so how strong the argument is depends on how likely the conclusion is, given that the premises are true. So again, we have to assume the premises are true, because this feature just says if the premises were true. So we're not asking, are the premises were true? We're just saying, if they were true, suppose they're true, would the rest of this stuff follow? Is it likely that the rest of this stuff would follow? That's the question of inductive strength. And the more probable the conclusion is to follow, if the premises are true, the stronger the argument is. So here we're working with a matter of degrees. Okay, so the strength of an inductive argument is a matter of degree. It's either stronger or less strong, depending on how probable, given the truth of the premises, the conclusion is to follow. How probable is it that the conclusion will follow if we assume the premises are true? Here's an example. Okay, I've heard strange noises in my room at night. The best explanation for these noises is that ghosts exist. Therefore, ghosts exist. Okay, this is an inductive argument. Again, in order to be an argument, something doesn't have to be a good argument. Think back to my argument about blueberries. Not a good argument. Okay, so this arguably is also not a good argument. Okay, I've heard strange noises in my room at night. The best explanation for these noises is that ghosts exist. Conclusion, ghosts exist. Okay, so what we're asking when we look at an inductive argument to determine its strength is, how likely is it that the conclusion is true if we assume the premises are true? Okay, and in order to be able to answer that question with inductive arguments, we have to know a lot more about the argument. So in particular, we have to know what kind of inductive argument it is. It helps to know that anyway, because different kinds of inductive arguments are going to have different things to look for. Okay, so we're going to have to look for different features of one kind of inductive argument to determine whether it's a strong argument, and then a different kind of inductive argument to determine whether that different kind of argument, inductive argument, is a strong argument, we'd have to look for a different set of features. Okay, so knowing what to look for is going to require that we know what kind of inductive argument it is. And this argument happens to be an example of what's called an inference to the best explanation, or an abductive argument. Those are two words for the same thing, two phrases for the same thing. And the question that's important with an inference to the best explanation is whether that really is the best explanation. Okay, maybe there's a better explanation that we haven't thought of. Okay, so again, this is an inference to the best explanation, or an abductive argument. And there are two principles we get here to determine whether something really is the best explanation when we're working with abductive arguments. The principles of simplicity and conservatism. Okay, the principle of simplicity, also known as Occam's razor, says that if you have a whole bunch of explanations for some observation, like the observation that you've heard strange noises in your room at night, if you have some competing explanations, the best one is going to be the one that explains all that you need to explain and is the simplest. That doesn't sort of add unwarranted assumptions into the explanation. Okay, so consider, I've heard strange noises in my room at night. Either there are witches that create mice, magical flying mice that set them free in the walls, and then the mice make those noises. That's one explanation for the noises in my room. Another explanation is that there are squirrels in the attic, right? Well, which of those explanations is better? According to the principle of simplicity, the simpler one, the one about squirrels, is better, because the one about squirrels doesn't add all these extra pieces into the explanation. Okay, that's what the principle of simplicity is about. It says if two explanations are equally good at explaining the thing you're trying to explain, then go with the simpler one. The simpler one is more likely to be true. The simpler one is the better explanation. Similarly, the principle of conservatism says, go with the explanation that fits the best with what you already believe. Okay, so that's why for many of us who may not believe in ghosts, the squirrel explanation is going to be better than a ghost explanation, because having squirrels in the world fits with what I already believe about the world. It fits better with my existing beliefs. And the ghost explanation doesn't fit as well with my existing beliefs. Now, the author also points out that maybe you're a ghost hunter staying in a haunted house, and so the ghost explanation fits better with your existing beliefs than maybe you're in a place where there are no squirrels. So it couldn't be squirrels. That's not a good explanation. So what's going to be the best explanation sometimes depends, if we're looking strictly at the principle of conservatism, sometimes depends on what existing belief sets we have. Because the question is, what fits best with your belief system? And if we have different belief systems, then we're going to come to different conclusions about that. That's why, again, inductive arguments are a lot messier than deductive arguments. We don't get that mathematical crispness that we get with deductive validity when we're dealing with inductive arguments, because the world is a messy place. And so trying to discern what's the best explanation for noises in your room at night is often a difficult thing to do. And maybe there are many competing explanations and you're not sure which one of them is correct. When I was lying in my room last night, I noticed that some of the paint on my wall in one little corner is starting to bubble. So I was wondering, why is that happening? Well, there were two explanations that I found when I Googled this question, and one was heat and one was moisture. So which was the best explanation? I still don't know. I'm still investigating, but I will try to keep you posted. Okay, another kind of argument is an argument by analogy, another kind of inductive argument. So we looked at lots of different forms of deductive argument. Now we're looking at lots of different forms of inductive argument. So far, the inductive argument we looked at was an inference to the best explanation. Now we're looking at an inductive argument that is an argument by analogy. And this argument says, 1, philosophy class is like English class. I've changed the example from the textbook a bit. 2, I always do well in philosophy class, therefore, conclusion, I'll do well in my English class. Okay, well, is this a good argument? Well, the first thing to know in order to evaluate it is to know that it's an argument by analogy. And when we're considering arguments by analogy, the thing we have to find out in order to tell whether it's a good argument is whether the two things we're analogizing, I think I got that word right, are relevantly similar. Are they alike in the relevant ways? So you may object to this argument by saying, this is not a good argument because English class and philosophy class are just way too different. And actually, in my case, they were so different. I did well in my philosophy classes and I did not do as well in my English classes. So that's evidence that that this is not a good argument, right? That these things I'm basing my analogy on, philosophy class and English class, are not alike in the relevant ways for me to be warranted in drawing that conclusion. Again, in an inductive argument, for it to be a strong argument, we want the truth of the premises. That is, if the premises are true, we want the conclusion to be very likely. And here, I'm saying it's not very likely because English and philosophy are too different. Okay? Okay. Here is another inductive argument. Oops, I guess when I click it moves forward, but I don't want to do that. I just want to erase this hyphen. Okay, here is our inductive argument. The sun has risen every day so far. Conclusion, the sun will rise tomorrow. This is an inductive argument, and it's what the author calls an enumerative inductive argument. What that means is that we're taking some sample, some limited set of things we've observed, and drawing a conclusion that extends beyond that limited number. And even in this case, just to one more potential sunrise, right? One more day after every day that we've witnessed the sun rising, which is every day of our lives. We're adding one more day. So we're not making that big of a step to the conclusion from the premises. We're going to see in the chapter about knowledge why Hume said we're not even justified in drawing this conclusion in this argument. We're going to talk about that later. But here we have an enumerative inductive argument. And again, we've been looking at different kinds of inductive arguments here. And for the inference to the best explanation and the arguments by analogy, we got different ways to determine whether the argument is a strong argument. Well, here we have a different way to determine whether the argument is a strong argument. And that has to do with sample size and whether the sample is representative. Okay, so what's that mean? Well, the larger the sample size, again, we're in an enumerative inductive argument, we are making a direct observation of some limited number of things, and then we're extending our conclusion beyond what we've directly observed. And what this is saying is that the larger the sample, the larger the number of instances that we've directly encountered, the stronger the argument is going to be. That is, the more likely it is that the conclusion will follow. Okay? The other feature that we have to pay attention to is whether the sample is representative. Have we actually gotten a sample that represents what we're extending our conclusion to cover? So let me give one more example of an inductive argument to make these clear. So if I say 70% of North Carolinians surveyed say they like peanut butter ice cream better than mango ice cream. And then draw my conclusion, which is that 70% of North Carolinians like peanut butter ice cream better than mango ice cream. Okay, here's another example of an enumerative inductive argument. And hopefully this shows why the sample size, the size of the survey, so how many people did we survey, the more people we survey, the more likely our conclusion is to follow. So if we call 3 people and ask them about ice cream, and well, we'd have to call 10 people so we can get 70% of those. Okay, so suppose we call 10 people and 70% of them, that's 7 of them, say they like peanut butter ice cream better than mango ice cream. Can we draw a conclusion about all of North Carolina? Well, no, because that conclusion is not likely based on the evidence we have. This sample size of 10 people does not give us a strong basis for drawing a conclusion about all the millions of people in North Carolina. But if we survey 20,000 people about ice cream, for example, then we have a better sample. We have a stronger argument, because if the premise is true that the results of our survey were what we say they are, then there's going to be a good chance, a stronger probability, a higher probability that the conclusion follows, that we can extend this information to make a generalization about all of North Carolinians. Okay, but we also have to have a representative sample. That's the other key here. And that means that if we only call children in North Carolina, for example, and then we're trying to make a generalization about all North Carolinians of all ages, that again is not going to give us good support for our conclusion, because we haven't surveyed a representative sample of North Carolinians. So it would be much better to call people at random, to choose people at random of all assortment of ages if we're drawing a generalization about all North Carolinians. Okay, so that's why our sample has to be representative as well as large enough. Okay, and remember, it's not cut and dry here. With valid arguments, it's either valid or invalid. There's no in between. With inductive arguments, they can be stronger or not as strong. And increasing the sample size is going to make the argument stronger if it's an enumerative inductive argument. But whether it's strong or not, there's no cutoff point where it becomes a strong argument. Okay, it's either stronger or less strong based on things like the sample size and whether the sample is representative. Now, is it strong enough to accept the conclusion? Is it strong enough that we ought to believe the conclusion? Well, that's going to depend on a lot of factors, given the particularities of the arguments that we look at. Okay, so we just looked at 3 different types of inductive arguments. Inference to the best explanation, or an abductive argument. We talked about how the question there is it really the best explanation? And we can use the principles of parsimony and the principle of conservatism to determine what's the best explanation. Then we looked at arguments by analogy, and we said the question there is, are the things that we're comparing relevantly similar? Are they alike in the relevant ways to really give us good evidence that the conclusion follows? And we looked at enumerative inductive arguments, and there we said, is the sample size big enough, and is it a representative sample that we are justified in drawing our conclusion? Okay, so these all have to do with the strength of an inductive argument. Now, just like we can evaluate deductive arguments on the basis of their structure, on the one hand, separately from their content, we can do that with inductive arguments too. So far, we've been looking at ways to determine the strength of an inductive argument. But of course, for it to be a good argument, it also has to start with true premises. Okay, even a very strong inductive argument isn't going to get us anywhere if it doesn't start with something that's true. And so we have this other notion, another term for an inductive argument that's strong and has true premises, and that term is cogency, or we say the inductive argument is cogent if it's a strong inductive argument with true premises. Okay, and that leads to the completion of our table here, because we've considered how to evaluate deductive arguments on the basis of their structure, namely, are they valid or not, and their content, whether they're sound. And we've done the same for inductive arguments, looked at whether an inductive argument is strong based on how probable the conclusion is given the truth of the premises. And we have this final notion to consider whether the argument is cogent, that is it a strong argument with true premises? And if it is a strong inductive argument with true premises, then it is a cogent argument. And that is the lecture on chapter 2. So I just want to say that I will be, or already have posted a number of additional study materials for this chapter. And we're going to spend 2 weeks studying this chapter, which means next week I'm going to give a lecture after I've seen how you do on the quiz, and after I've seen what questions and comments you have about this lecture, then I'm going to do another lecture to help address some of those questions and comments and things that may still be unclear. And you'll have had a chance by then to look at the additional study materials. So I'm going to post some sample validity exercises so you can look at different argument structures and determine whether they're valid. We just looked at the most basic, simple structures in this lecture. In the exercises I'm going to post, there will be more complex argument structures, and you'll need to be able to decide whether they're valid or not. So after you take this next quiz, I'll have more to go on as I record the following lecture as a follow-up. Lecture 4 will be a follow-up to this lecture, in which I try to help with some troubleshooting and try to support you all as you study this very complicated material. So that's one way to say, please ask questions and give me your feedback, and let me know if I can help you in preparing for the quizzes and mastering this material. Have a great week. I will see you soon.